just wanted to do a quick review of kind of the insulin sensitive pathways within skeletal muscle. This figure is in one of the modules, the energy balance modules. So just wanted to review that this real quick. So what we have is a scenario where glucose and insulin are present as glucose goes up due to food intake. So this is a resting state, non-exercise situation. We'll talk about exercise later. Insulin will be secreted, and with the goal to insulin binding to the receptor, and then starting a cascade of events in the insulin signaling pathway, with the end result of GLUT4 translocation to the cell surface to bring in glucose, and then that glucose can undergo glycolysis, or will. You can also go to glycogen here, but for this example, undergo glycolysis with pyruvate via PDH to acetyl-CoA. And then the interesting thing happens if there's excess glucose in the blood, this glucose go to acetyl-CoA. If it's not used for energy production, acetyl-CoA carboxylase will convert it to malonyl-CoA, which will inhibit carnitine palmitoyl transferase and limit fatty acids going into the mitochondria. In essence, there's enough glucose to drive ATP production for whatever energy is necessary in this cell. And so this is a way to decrease fat oxidation, which is what we see with after a meal with insulin. So we'll get to that here in a second. So this fatty acetyl-CoA will lead to DAGs, diacylglycerol, ceramide, and then the fatty acetyl-CoAs in general. So over time. So this doesn't happen just with a meal. You can induce this in a lab or with a massive food challenge potentially. But over time, if the cell becomes saturated, this is where all the excess carbohydrate, the carbohydrate insulin model comes from, is this situation. But remember, it's excess. And so it's not a cookie, it's not a soda, it's not a bagel, it's repeated intakes of excessive amounts, and that's contextual based upon the person, amounts of carbohydrate foods. And this is glucose. It's not sugar. It's not starch. It's glucose. Now, the starch molecules can become glucose, but it's glucose, not blood sugar. Anyway, and then over time, these signals will impede the insulin signal. And so, in essence, it's a way for the muscle cell to say, hey, I'm full. I can't take on any more. And so it's while, so it's kind of like when your car is full of gasoline, it'll shut off. This isn't a switch, but so it's not binary, it's not on off. But this will signal that, hey, we're getting full. This glucose needs to go someplace else, or we need more insulin to move the same amount of glucose. So that's just a summary. of this aspect of the class, or this portion of the energy metabolism content. More to come. Thank you.